So in this video, we're going to be discussing every LangChain component. Now, before I start, I would like to make a clear distinction between components and concepts. So there are components and there are concepts. If you look at the LangChain concepts page, you see there's a mix of components and concepts. So this video is going to focus on components and not concepts. Concepts like runnables and stuff like that are not going to be discussed in this video, but we're going to be looking at chat models, we're going to be looking at tools, we're going to be looking at prompts and the core components in LangChain. And let's begin with the most important one, in my opinion, which is the chat model. Yeah, the chat models. Now, chat models in LangChain are an abstraction for you to work with the popular LLM providers or with any LLM provider. Now, there are the major LLM providers, your OpenAI, your Gemini, your Anthropic, and they all have their packages. We have LangChain OpenAI for the OpenAI SDK. We have LangChain Gemini, or rather LangChain Google Gen AI. That's for Gemini models, and we have LangChain Anthropic for the Anthropic models. There's also for Mistral. There's for Grok also. Now, these are classes that help you interface with the LLM providers themselves and bring all their features into the same unified interface that every chat model or every LLM in LangChain is going to use. Because one of the main selling points of LangChain is that it helps you to work with any LLM with a unified interface. So these chat models are what takes the APIs and the SDKs of these known LLMs and brings them to conform to that unified interface. So that's basically what chat models do. So like I said, you have chat OpenAI, you have chat Anthropic, you have chat Google Gen AI, and what they all do is that they make sure that you have a uniform interface to use any of these language models. Next, we have message types. Now, for you to communicate with a model, an LLM, you send messages to it. And there are different types of messages that you can send to it. The popular one that we just type into our chatbot is what is called the human or user message. That is the question we want to ask it, the task we want to give it, the data we want it to summarize, any stuff that we just want it to do. That is what goes into the human or user message. Even when we're doing few shorting, when we're few shorting our prompts, it's still a human message. Then we have messages like the SystemMessage, which is used to pass background instructions to the language model for the current session or for the current context window. We also have the response that comes back from the language model, which is what is called an assistant message or AIMessage. There are also standard messages for tool calling, which are called tool messages. So those are the message types. We have different message types in LangChain, and what they basically help you to do is communicate and control the communication with your language model. Then we have prompt templates. Now, what are prompt templates? Prompt templates are basically templates for creating standard prompts. Yeah, they are templates for creating standard prompts. Prompts are composed of messages. A prompt is one or more messages. So most of the time, the prompts that you're used to just contain one message, which is the human or user message. But you can also have a prompt that will contain a system message. You can have a prompt that will contain a tool message. You can have a prompt that will contain a sequence message that will help you few short your conversation with your language model. By the way, few shorting is basically the way whereby you add examples to your prompt in order to guide the language model in how you want the response to be. So there are different types of standard prompt templates in LangChain. There are prompt templates for chat, which consists of which is an array of different types of messages. Chat prompt templates can take different types of messages: SystemMessage, AIMessage, tool message, a whole lot of messages, even placeholder messages. You can take a bunch of messages and pass it to your language model. We also have the basic prompt template, which can just take a single message, just like a zero-shot message to your model. There are also prompt templates for multimodal activities, even though these days ChatPromptTemplate seems like the prompt templates that can do everything. So most of the time, a lot of people just use ChatPromptTemplates because they are that versatile. So those are prompt templates. They are basically blueprints for you to generate standard prompts to communicate with your language model. Then we have output parsers. Now, what are output parsers? Now, communication to and through a language model is in natural language. It will go as free-form text, even though there are tokens behind the scene, and it will also come back as free-form text. If you are going to be using if you're going to be using the data that comes from the language model in the context of building an application, you want to, most of the time, pre-process it. You want to process it before you have the final output, because you might need a string. And it comes with this array of messages and even a metadata along with it. You might just want the string message of the main content of the response. You want to extract it as a string. And sometimes you want a JSON structured output. You want your output to come back as JSON. You can also want it to come back as XML, or come out comma separated. So this is what output parsers help you to do. They help you to extract your response from the language model in a format that is suitable for the next step in your application. So if you want JSON out of your language model, you use a JSON output parser. If you want string, you use a string output parser. If you want XML, you use an XML output parser. So there are different types of output parsers in LangChain that can help you get a more structured output out of your language model. Even though these days we now have structured outputs where you can define this schema with which the data from the language model should come out. So I might want to say output parsers in LangChain are kind of going out of fashion, but they're still very, very useful for very, very simple steps within a workflow, within a chain. But these days, there is more structured way to get outputs from your language models, especially with the advent of tool calling, because tool calling requires very structured output from the language model. So that's output parsers. Then we have document loaders. Language models have a knowledge base, and most of it, because they are pre-trained, most of their training has a cutoff date. I think GPT-4 is October 2024. So there's always a cutoff date to the training of the language model, meaning that they don't have access to very recent data. For example, the Champions League 2025 was completed, I think, 2 months ago. I don't think GPT-4 can tell you what that is, because its cutoff date is like October 2024. So it can't tell you the winner of the Champions League. So you might need to load that information from the web. So that's one type of information, current affairs and stuff. Sometimes it's domain information. As vast as the knowledge base of these large language models are, because that's where their name comes from, large. That's where the large part of their names comes from. They're not privy to your private information. They don't know about your company documents. They don't know about your company finances. They don't know about your company's documentation and stuff like that. They don't know, especially if it's not on the public web. They don't know about it. So if you have in-house domain information, you might want to feed it to CSV files like Excel, to PDFs, and sometimes even video. So document loaders help you to load in this information. By the way, the next 4 components that we're going to be talking about are very, very essential to retrieval augmented generation, RAG. They are very, very key to them, because what happens in RAG is that you pull in domain information, you save it in a vector store, then whenever you want to prompt your model, you retrieve the relevant documents that are relevant. You retrieve the documents that are relevant to what you want to prompt the language model about, and then the language model is able to use that as context for its generation. So document loaders help you perform the first step in RAG, which is get that domain information loaded in from the data source. It can be from a database, it can be from PDF files, it can be from CSV files, it can be from text files, it can be from Microsoft the Word documents. They just help you load in stuff. So that's what document loaders do. The next component is text splitters. Now, this is very important, because when you load in your documents, you get a list of documents. So when you load in, let's say you load in a PDF file, you can have each page as a document in a list. In a Python, let's talk in Python terms now. So you have a list, and each document is going to be a dictionary. Each document is going to be a dictionary, and each document in that list can represent a page in the PDF file. So if your PDF file has 120 pages, you're going to have 120 documents in there. Now, sometimes this data can be too large when you want to go to the next stage of RAG, which is storing this document in your vector stores. It might be too large to process. That's when we want to go to the next step. It might be too large. So you want to split them. You want to split them into chunks. You want to split them into more manageable chunks. There's even a context preserving strategy that you can do, whereby you can say that each chunk should have an overlap. Because naturally, you just want to do like a clean cut. Naturally you do like a clean cut. Like, okay, you stop at this sentence, then the next chunk will start from the next sentence. But sometimes that can help you lose context, because the whole document is a whole, and you want to maintain context within the whole PDF. So you can tell it, you know what, have an overlap. Let each chunk cross into each other by, let's say, 20 characters or 50 characters, so that they can kind of know how they are connected. They can be able to recognize how they are connected. So you can do that with text splitters for any type of information that you want to source. But it's important to use them, because the next step is going to be embeddings, generating embeddings, which is also another component in LangChain, which is also another function that LangChain can help us perform, which is generating embeddings. Now, why embeddings? If you watch the AI dictionary series, you will have seen us define embeddings. Now, embeddings is the way language models understand data. Now, even though we are communicating with language models with natural language, that's not how they see it. Because that's not how computers work. Computers work with numbers. So this every piece of information that we want a large language model to read has to be converted into vectors. They have to be converted into vectors. Large language models see all our data, see all the relationships between them as vectors. They see it as vectors. So for us to be able to use to have this information in a way that a large language model can process, we have to convert it into those standard vectors. And the process of converting it is called embedding. The process of converting raw data into vectors for large language models is called embedding. It's called embeddings. And the vectors you generate are called embeddings. So, and these are also done by language models. There are some small language models that help you do it quick, and all the LLM providers like OpenAI, Claude, they also provide their own language models to help you generate embeddings. Because you cannot use the embeddings class, you cannot use the embedding system of one language model to get your information into a vector store and read it with a different embedding model. You can't do that. You have to use the same thing that you use to encode must be the same thing that you use to decode. So embeddings are how we convert our raw data into those vectors that can be used in our prompts. And they are basically, the next step is to just store them in our vector database. Which is another interface that LangChain provides for us. LangChain provides vector store interfaces that we can use to interface with different popular vector stores like Chroma, like Weaviate, like Pinecone. And what vector stores basically do is that they store data. They store embedded data. And they store them based on how they are related to each other. They store them based on meaning. They store them semantically. You can also search them by keyword. They provide capabilities for that, but most of the search is a semantic search, which kind of groups together data based on meaning. For example, if you query it for love, even though you have a novel that doesn't have love in its title, the fact that the content of the novel talks about love is going to pick data from the novel, and it will also pick data from another poem that is a romantic poem, some love letter someone wrote somewhere that's also in the database. So it can get you context based on meaning. So if you tell it, write me a story about love, the vector database can be queried with the word love, and it will be able to gather all the information, all the vectors that are related to love, and retrieve it for context for your prompt. So vector stores are basically where vectors are stored, which is numerical representations of real world data stored semantically. Then next we have retrievers, which is like the second to the last step in RAG. Like I said, the next components we are discussing are RAG based. So retrievers, and what retrievers basically do is that they help you search vector stores. So you give a retriever your prompt. Let's say you want to query something about Harry Potter. You just ask it, tell me what you know about Harry Potter. So it will take that, go into the vector store, and retrieve all the relevant vectors that are connected and related to the word Harry Potter. Even if they don't mention Harry Potter. Yeah. it will just take everything that is related to Harry Potter and use it to, and you can then take that to build context for your prompt, which is the generation part. So you look at RAG, it says retrieval augmented generation. So you retrieve relevant documents to augment the generation from your large language model. So that's what retrievers do in LangChain. They're basically tools for searching your vector stores, and they can search it. They search it by default semantically, but you can also do a keyword search. Then we have tools. Tools are how LLMs interact with the external world. Yeah, they are how they interact with the external world. Even if your LLM is going to have to take an action within your application, you still have to use a tool. Let's say it needs to update your database with some data. It needs to write a file to a location. It needs to call it an external service. It does everything with tools. So tools are how the LLM takes action. That's how the LLM takes real world action. And LangChain provides capabilities for you to turn your simple functions and classes into tools that can be invoked to based on the information that they get from the large language model and the recommendation that they are to be called. Those tools can be invoked and they are going to perform their function. Though they can help you retrieve something like weather data from a weather API, stocks data from a stocks API, and you can either use that information for context within your application or use that function to perform an action like send an email or send a Slack message and stuff like that. So, and tools are at the core of agents, because agents are basically autonomous systems that can perform real world actions. So tools are a major part of AI agents. Now, memory. So memory is basically how LangChain keeps context within your LLM applications. That is basically it. It's how LangChain keeps context within your LLM applications, but it can be more. It's more complicated than that. So first, there's short-term memory and long-term memory. Short-term memory and long-term memory. The short-term memory is what is in the current session of your conversation with the language model. Your current session with the language model, your current context window. That is the short-term memory. That's the short-term memory. Is the working memory, is the hot part. So it is the active memory, the memory that is currently being used to process what the LLM is going to generate as your responses. Then we have long-term memory, which is information that you have persisted probably from previous conversations, from company data, domain information and stuff from the web that you've persisted into a store like a database or a vector store that can be retrieved to build context for subsequent prompts that will be sent to your large language model. So that's persistent memory. And you can even break down persistent memory into three. There's episodic memory, which is memory of things that have happened in the past. There's procedural memory, which is the memory of how to do things. Memory of how to do things, like, okay, for example, if there's a specific API you always call, that can be in a procedural memory, so the LLM will always call that API with the same steps. So you don't need to remember every time or construct new strategies to call that API every time. So it's more like how you learn how to fix a car tire. You've already learned the steps. So whenever your tire goes down, you know the steps to take to fix it. So there's procedural memory, there's episodic memory. There's one other type of memory. Let me see if I can. Can't really. Let me see. Okay. There's semantic memory. Yeah, semantic memory, which is information about an entity. So what the LLM understands about books, what the LLM understands about a particular location, let's say New York, what the LLM knows about you. Yeah, like all those information that the LLM is keeping about you is semantic memory. It's defining you. It's giving you a meaning. It's trying to say what you like, what you're about, your attributes, and the kind of actions that you like to perform. So yeah, that's memory. Then we have agents. Agents are basically applications where the LLM has been given control. Your typical applications follow a defined path. They follow defined steps. Most of your runnable chains that we're going to be seeing later, most of the workflows you construct with LangChain, from runnable parallel to runnable branch and sequence and stuff like that, they still follow a path that is defined by you. But for agents, the LLM defines what is the best workflow. Yeah, it defines what is the best workflow. So it's basically acting as a brain. Then you give it tools. You give it context, and then you tell it, do this. tell it do this. Let's say you tell it remind me to send this email, or rather send this email to so person at so time. So it tells itself, okay, first I need to set a timer. So if it uses a tool to set a timer, then it tells itself I need to construct the email to set at so time. Then it also now tells itself I need to find a way at so time to run this particular function to get it to send this email. So it just does that all by itself. It does that all by itself. And there are different architectures, there are different patterns, and each patterns kind of turn the knob between how much control you're giving your agent. But the one very popular one with LangChain is called React, the React pattern, which uses the steps of a series of steps called thought, action, and observation. Thought, action, and observation. So what it does is that you give it a task, it thinks, oh, I need to start this task, I need to do this. Then it now goes to the next step, which is action. It takes an action. Then when the action, which is most likely going to be a tool call, when the action produces result, it then checks the result, which is the observation phase, then determines whether it has gotten the answer already, or it needs to repeat that cycle, which is come up with another thought based on the new information, take another action, then observe again. And it keeps going through that until it observes that it now has the perfect answer for your query, and then it just stops. The loop just stops. So there's always a criteria that makes that React loop of thought, action, and observation stop. So yeah, that's agents, and that's all the components we're going to be looking at in this video.